Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video. And today's video is about another interesting topic in the subject short range wireless communication. And in this video, we're going to see UWB transmitter and receiver. In previous video, I have just said what is UWB technology, what are the different applications of it. And today we're going to see about UWB transmitter and UWB receiver. And before starting this video, I would recommend you people to go to the previous video and watch what is UWB technology so that you will understand the basics of UWB. And after that, you can study about UWB transmitter and receiver, which will be very useful for you, right? With this, we will start with UWB technology, where in previous video I have already said what is UWB. But UWB is a radio technology which uses very low power, but it is a very powerful technology because it has a very wide bandwidth, so that it is differentiated from other short range communication because it can achieve higher data rate and it has high capacity. That is because of wide bandwidth. It covers from 3.1 gigahertz to 10.6 gigahertz. And because of this wide bandwidth, it has lots of applications. And notable applications includes radar, tracking, precise location, all those things, right? We already seen some characteristics of UWB. Very important characteristic is wide range bandwidth, right? Much wider bandwidth than other short range communications, right? And similarly, UWB transmitters or UWB signals cannot be easily detected like the ordinary radio receivers, with the ordinary radio receivers. But that is, it can exist concurrently with the existing wireless communication, and it cannot be easily detected, as I said before, right? And these are the other advantages where it has very low spectral density, right? And because of that, the chances of getting interference is very minimum, and high immunity to interference from other systems as well. Low probability of interception and detection, as I said, it cannot be easily detected. Low power consumption, and it is ultra fast when compared with other short range wireless communication. And it has high multipath immunity and high data rate, fine range resolutions, right? All these are advantages of UWB technology, right? And here, the transmission operation of UWB and the reception option of UWB is very unique. It is not like the other radio technology, where we can call UWB carrier, UWB pulse as a Gaussian monopulse, right? I'll explain UWB transmission and reception, and we have already seen the applications of UWB in previous video. Lots and lots of application. Apple AirTag, smart car access, healthcare sensors, wireless printers, all those things we saw already, right? And coming to the transmission and reception, right? And before transmission and reception, you have to understand that UWB is not like a conventional radio system where we will do up conversion, down conversion, and transmit using band pass or passband frequency channels. Here, you will generate the UWB pulse and you will transmit that pulse using baseband techniques. What is baseband techniques? Right? Baseband techniques is something where you will directly transmit the message signal. Baseband transmission is transmitting the message signal directly without doing any modulation, right? So UWB works in that particular technique. USB, that is baseband techniques, and where you will be able to generate a sequence of pulse in a very short intervals, and there should be some variation between those pulses to identify zeros and ones. And this is a good example, like this is how an UWB monopulse will be, right? A Gaussian monopulse, we say. And say for example, if this is considered as nanoseconds, the width of this pulse is 0.5 seconds. You can see this is 0.5 seconds. It is the width of this particular pulse. And when it comes to power spectrum, you can see the power spectrum, it has a good power spectrum. And the maximum power spectral density occurs at 2 gig, where you can see this is the maximum power spectral region, right? This is how single monopulse of UWB will be, right? And coming to transmitter and receiver, as I said, the transmission is nothing but we will transmit a sequence of pulses like at the sequence of pulses at regular intervals, right? And that regular intervals is determined by the pseudo random codes, right? And definitely that sequence of pulses will have some variations to understand what is 0 and what is 1, right? And at the receiving side, what we will do is whatever signal that is transmitted, that is received, and again the same pulse which we have used in the transmitting side, that will be used as a reference, and both these things will be compared, and based upon this particular comparison, we will be able to detect the signal it is 0 or 1, right? So that is what explained in this slide. You can see in order to pass the information over UWB communication, a train of pulses must be transmitted with some difference in characteristics so that we can able to identify what is 0 and what is 1, right? When we say train of pulses getting transmitted, then definitely there should be some short time interval, right? That short time interval is determined by a pseudo random manner. It can be done by a pseudo random code which generates that particular time period, and with that we can able to use the pulse generator to generate a sequence of pulses, right? And during reception, as I said, you can see the transmitted pulse is done correlating with the received signal, and where you will use similar pulse which is used at the transmitting side. And after that, you will do detection sampling, and then the signal will be detected. A large number of communication is possible, right? A parallel communication links can be maintained simultaneously because of using pseudo random sequences. This is the principle of UWB technology. And if you don't understand this particular information, the theoretical information, definitely you can understand through this particular diagram where I said transmitting in the transmitter side, we will just generate a sequence of pulses, correct? Right, you can see this it generates a sequence of pulses with the help of this pseudo random code sequence, right? With this pseudo random code sequence, it will generate sequence of pulses with some variations where you can able to understand which is 0 and which is 1. And that particular pulse can be sent to this shaping network, where this shaping network shapes the particular signal. It will remove the unwanted signal, distortions everything, and it will send the transmitted signal, smooth signal that is transmitted. And at the receiving side, you know already what is the working of all these things we have already seen in wireless communication elements. What is integrator, sampling and hold, all those things, right? This particular part is used as a detector where the received signal will be integrated, and then it will be sampled at regular intervals, and using that sampling, then it is done by signal processing, and then we detect whether it is 0 or 1, right? And one thing here is we will compare that particular signal. We can see the comparison. The received signal will be compared with the pulse generator. You see this pulse generator, it is the same pulse generator which is used in the transmitting side. So it will generate the same sequence of pulse, and now this pulse will be used as a reference pulse, and it will be compared with the received pulse, and then the signal will be integrated, sampled, and you can able to identify the original data. This is the whole process of transmission and reception. One important thing here is we can also achieve synchronization between the received pulse and the pulse generated here using this tracking and uh, acquisition and tracking, which works as like a feedback where to get synchronized with the received pulses, right? And this is what explained here in this particular diagram, where you can see in this diagram uh, the received signal, right? You're getting a received signal, and that signal is compared with the local sequence of signal, and this is combined, and we'll get a correlator output, and this output is done signal processing, sampling, and then we will find out whether it is zeros or ones, right? Now you can see here I already said in transmitting side zeros and ones, that is train of pulses will be transmitted, but there will be some difference in identifying zeros and ones. You can see here the one, right? The one is represented like one negative line followed by the positive line, right? And you can see one negative line followed by the positive line for one, right? Whereas zero is represented like one positive line followed by the negative line, right? One positive line followed by the negative line for 0. And you can see the local template, it will has the same template where it will have a training sequence. You can see all these things will be same pulse, where now if you want to compare this signal, we are going to multiply this signal. Like we consider this as f of t, and we consider this as g of t. And if you're going to compare this signal, you're going to multiply this signal. Once again, you'll understand the difference because all the signals are same. So this has different pattern and this has different pattern. And so even after multiplying, the pattern will remain same, right? So the correlated output will be like this, where after correlation, right, it will be integrated and it will be sampled at regular intervals where you have some sort of a delay here. And after sampling, we can able to identify whether the transmitted bit is 0 or 1 with a particular delay. You can see this is the delay for one time period. And after that, we can able to determine the same transmitted sequence 1 0 1 0 0 here, right? This is what explained in this particular slide where you can see one monopulse is represented by one negative line followed by a positive line, where 0 is represented by positive line and negative line, and the synchronization sequence, that is f of t and g of t, that is compared, and then sampling, signal processing. After doing all those things, we can able to find out the output with one simple period delay, right? So this is the overall working of UWB transmitter and receiver, right? And whatever I said regarding pulse generator, you can see short impulse that is generated uh, and it is sent to the shaping network, right? It produces the required output spectrum, and if needed, we can also integrate a lot of special circuit elements like tunnel diodes, recovery diodes, pulse generator, right? And these pulses, right, on the receiving side, it will create a replica of the transmitted pulses using the same pulse generator. And I have said acquisition and tracking block is used to achieve synchronization between the received pulse and this training sequence pulse, right? And once it is done, once the correlation is done, right, like we will integrate and sample, and we will be able to detect the output, right? So this is the overall working of UWB transmitter and receiver, right? So today what we have seen is we have seen UWB technology, just an introduction about UWB technology. Along with this, we have seen how UWB transmission and reception takes place. I believe this video will be very useful for you. Thank you very much, my dear students.